In the previous part of the lecture, we talked about class invariants, and the class invariant is encoded as assertions in Java to be checked at the end of each method. Let's just verify this again. So you can see this particular class invariance that the balance should be strictly larger than 0 is checked at the end of the withdraw method. So now, my question to you in the previous video at the end of it was really about what if the implementation for the withdrawal. Over here you can see it is done correctly. The balance is actually correctly subtracted. However, what if the implementation was wrong by the supplier? When your development gets more and more complicated, you can no longer expect the supplier to always do their job properly. So you have to make sure the contracts, which is for the benefits of the clients, must be as complete as possible. So I claim that line number 9, over here, line number 9, the class invariance is not sufficient to make sure that faulty implementation by the withdrawal supplier can be caught at the runtime. Let me illustrate to you very quickly. Okay, so now without returning back to the slides, let me just show you. Basically, we're now in this part here. We want to do a fourth attempt when there's actually a faulty implementation. Okay, and then before I get to the slides, I want to illustrate everything that's critical on the iPad, so we can walk through the slide afterwards very easily. So now everything stayed the same except, okay, so let me just remind you again over here. So the precondition here, actually let me highlight this way. Negated precondition, and also we got this particular class invariance. That's what we learned from the previous version. So now what's really changed is this particular guy here. So here we say this dot balance is assigned to its current value plus the amounts. So this is faulty. It is not what it intends to really achieve. So it's increments rather than decrements. So now the question is the class invariance as is good enough to catch that? So that's the question. So this is your invariance. Okay, so here's my challenge to you. Is this contracts good enough or complete enough? Good enough to signal an error at runtime. If it is able to signal such error for the faulty implementation, then our design is acceptable. Otherwise, if there's something wrong, but the invariance alone cannot actually catch that error, so that means our design is insufficient. It has flaw. Okay, let's argue that the latter is the case, it's flawed. So now let me just illustrate to you exactly the scenario over here. So supplier's code, remember that's the faulty implementation we talked about. And let's think about this particular scenario. So now we are in version number 4. I'm just creating this particular version, right? Remember that version that we are talking about, right? So now we declared supplier objects Jeremy, and then Jeremy's initial balance is simply 100. Okay, and then we want to withdraw $50 from Jeremy, and don't forget this particular withdrawal is wrongly implemented. Okay, let's see exactly how we can see this. Let's trace it. So now when we call the withdraw and we try to call to withdraw 50, and at the moment balance is actually as initialized, which is 100, right? We're trying to withdraw 50 from 100, and the error condition is not going to be satisfied, right? Because it's positive. 50 is positive, and also it's affordable. You can definitely withdraw 50 from 100. So the first two are actually okay. So the two error conditions will be bypassed. So now this else part over here is going to be executed, and this balance is actually currently 100, and then the amount is actually 50. However, you're going to add it up and then reassign. So now this balance will become 150. Okay, so now we know that something has gone wrong, because if you withdraw something, you definitely should really decrease your balance. Otherwise, again, you should really introduce me to join that bank, please. So now for line number 10 and 11, let's now use a different color to emphasize. So this is the only contracts that can actually check for error. That's the only one. That's a class invariance at the end of your method. So now, will this particular contract pass or fail? Indeed, it's going to pass, because this get balance is going to be the wrongly calculated 150. 150 is actually larger than 0, correct? So it's going to be true. So now, as far as the class invariant is concerned, remember the class invariant for the account class is every resulting balance for the objects should be positive. And 150, even though it's wrongly calculated, is still positive. Of course, it's going to pass the invariance. So that means we are short of the contracts. Okay, you can see Jeremy's balance after withdrawal 50 has now become from 100 to 150. So that's definitely wrong. So why is this wrong? Remember, when something goes wrong, when we talk about what a good design is, when something goes wrong, there should be some contract violation, and there should be exactly one party, client or supplier, to be blamed. But it's not the case over here. So that's why the design is flawed. Over here, let's go back to the slide. I want to show you one more thing. Okay, so everything has been talked about already, so we don't really see any contract violation. A good design should really show that since the implementation is actually wrong, so it should really violate some contracts. Okay, and apparently this particular contract is not applicable to all the method call. So that should not be a class invariance. You only put a Boolean expression, for example, balance larger than 0, if as a class invariant. You only put a Boolean expression as a class invariance if that condition applies to every end of the method, to the end of every method. Let's say withdraw and also deposit. However, what really should be checked is specific to how the withdrawal should be done. So that's why this condition here should not be considered as a class invariance at the class level for the account. Rather, it should be a condition that should be true at the end of this particular withdrawal condition. And we call that this method specific condition to be checked at the end, post condition. Okay, so that's the last components for the design by contract I would like to discuss with you. Okay, that's a post condition. Okay, so that's the scenario that we talked about before. The resulting value 150 satisfying the invariance, but it should violate some withdrawal specific post condition. And this is something we would like to really add to our design. So in the next video, we actually show you how you can add the so-called post condition.